How do you know you're real? What if you live in the Matrix? Is the morsel you put in your mouth real? What if a simulation tells your brain that the bite is delicious and juicy, but you're not actually eating anything? This idea is not just the subject of the Matrix movies, it is also known as the simulation theory and is frequently brought up not only by ordinary citizens but also by extremely popular names such as Elon Musk and Neil deGrasse Tyson. This topic continues to be discussed in a variety of contexts within the philosophy and science community. Computer scientist Roman Yampolskiy claimed in a program he attended that artificial intelligence could be the tool that will save us from this simulation. But lo and behold, even though simulation theory is so popular, no one has yet explained in detail what the argument at the core of the theory is or why we should take this possibility seriously. Here we are with you today. We will learn those reasons. Gather around, let me tell you what the simulation argument is, what it claims, and why we are almost certainly not living in a simulation. Cosmologists are using massive supercomputers to produce extremely detailed simulations to better understand the universe and illuminate our physical past. He has made such great strides in this regard over the last few years. It has now become almost impossible to distinguish between simulations of the universe and real images. You can even do a very simple but still impressive version of this by playing simulators like Universe Sandbox. You can interact too. Depending on the depth of the simulation, experts can generate stars, star systems, and even planets on the computer. In fact, depending on the level at which those planets are simulated, it may even be possible to provide the conditions that would lead to life on some of them and simulate single-celled life. And the rest is a simple evolution simulation. In other words, we have already started to transfer what is in the real universe to computers. And this is just the beginning. Just think, just 40 years ago, we were playing Tetris. Now we are immersed in hyperrealistic computer games. Have you seen scenes created with Unreal Engine V? Have you played games that are still in beta like Bodycam or Unrecord? Look, what you are watching right now is not a video, this is where game simulators have come to. What kind of games will we be playing 40 years from now, especially when technologies like VR experience their own revolutions? But will we be able to distinguish them from the real world in 4,000 years? When we get punched in a game, our muscles will contract uncontrollably. Will our noses bleed? Because I'm not talking about glasses or anything. Thanks to the increasingly developing brain-computer interfaces, electronic circuits that we will connect directly to our brains will be able to create unreal images, sounds, and feelings in our minds. Games and hyperrealistic simulations will be able to send real signals to our bodies through our brains. When we train our rapidly developing artificial intelligences in these hyperrealistic simulations, perhaps some will evolve consciousnesses that feel like they live in a real world. In literature, we call this kind of future the post-human phase, which also gives its name to transhumanism. In summary, in this phase, humanity will be able to create universe simulations so realistic that the consciousnesses within them cannot distinguish them from reality. This is exactly why simulation theory pushes us to question our own reality. How can we be sure that this ultra-realistic experience we're experiencing is physically absolute reality? So what if we are in a simulation produced by a civilization that has passed to its own post-human stage? But this is a very strange claim, because, for example, I have known that I have existed for over 30 years. I have birth photos and such. Well, my mother and father know it too. All my friends know it too. Likewise, everyone I know knows that they exist. So how and at what point could the simulation have started? Frankly, it could have even started last Thursday. Just think, yes, we know not only from our own past, but also from millions of books written over millennia. And we know of hundreds of thousands of fossils and the geological record spanning billions of years. But all of this may have been simulated last Thursday, and is being presented to our consciousness as if it were ancient. It may also be that our memories are being created consistently by the simulation, and are being simulated as if everyone were remembering very old memories. This view, known as last Thursdayism, if the universe is a simulation, might be a perfectly reasonable possibility. You could also try to get out of it by saying I think, therefore I am. But no one has ever claimed that you don't exist. Consciousnesses in simulations are just as real as consciousnesses in the real physical universe. At least the main debate isn't about their reality. Only one is made up of real quarks and atoms, and the other is made up of computer codes that simulate those quarks and atoms. So how do we know that our quarks are real quarks? So how can we tell if the universe is a simulation? Unfortunately, there is no easy way to do this, because a civilization that can create a simulation so realistic that it is indistinguishable from the real thing is likely to be able to create consciousness within that simulation, will also be able to write codes that are successful enough to deceive easily. However, no software is perfect. Therefore, the general working principles of our universe, trying to find problems that we see as inconsistent, referred to as glitches in the Matrix movies, could be an experimental step we can take in this direction. Because these errors are caused by the simulated universes. Due to the need to model with discrete pixels. This type of modeling will create some observable problems by conflicting with the physics we know to be continuous. But it is always a problem to prove that these discoveries, which would be categorized as an error in the simulation within the framework of simulation theory, cannot be explained by other, more mundane explanations. Therefore, the simulation theory, or more accurately the simulation hypothesis or simulation argument, does not directly provide evidence for simulation. He tries to present a more rational argument by trying to show us how likely it is that we are in a simulation. And this argument rests on four basic assumptions. First, everything in the universe, from human consciousness to quantum mechanics, from stellar astrophysics to nuclear chemistry, from psychiatry to microbiology, must at some point be modeled on a computer. Because if something in the universe has a nature that cannot be simulated, then we cannot speak of simulation theory. But from what we have seen so far, it seems possible to transfer all the qualities of the universe that we know onto a computer in one way or another. If not now, then very soon. Second, the place of humans or any other consciousness in the universe should not be special. In other words, consciousnesses like ours must be able to emerge completely naturally, without requiring any supernatural intervention. If for some reason consciousness is not completely physical, then again, we cannot speak of simulation theory. Because in that case, that first civilization that was physically real could not create a consciousness on a computer no matter how hard it tried. But again, all the evidence we have indicates that consciousness is probably purely physical. So we have checked that too. Third, technology produced by conscious beings should not, for inherent reasons, tend to destroy its creator. After all, if consciousnesses that produce superior technologies are ultimately destroyed by these technologies, then the first real civilization that exists and will create the first simulation will also be destroyed by the technology it produces and may never initiate simulation theory. In other words, if naturally evolving consciousnesses are inherently incapable of properly mastering technology, that is, eventually atomic bombs, artificial intelligence, nanorobotics, bioengineering, and the like, if they are biologically inclined to destroy themselves with breakthroughs in similar areas, then we cannot talk about simulation theory. In other words, biological consciousnesses must not only be intelligent, but also intelligent enough to not forget themselves. Frankly, I'm not so sure about this, but let's assume it's valid for now in order to move on to the argument. Fourth, conscious beings must have a strong interest and concern for their own past and existence. After all, if civilizations are not trying to understand their past and current existence, they probably won't be inclined to create simulations of themselves or similar consciousnesses. Or maybe they are interested in their own past, but they may not find it ethical to create a hyperrealistic simulation of themselves. Because this is the era we live in. There is a lot of pain, death, evil and disease. Maybe they don't want to take the responsibility of being the creators of the consciousnesses that will experience it. But as we see the inherent curiosity of existence found in us and all other animals, it seems likely that many consciousnesses will have this kind of curiosity and drive, and at some point their curiosity will trump ethics. So if these four premises are true in any way, then we have a very interesting situation. As the Fermi paradox we discussed earlier predicted. At some point in the spatial and temporal vastness of the universe, consciousness must have emerged, evolved, become more complex, and built civilizations. These civilizations, at some point, they must have wanted to simulate their own past. Just as I explained at the beginning, we make simulations for evolutionary biology or develop simulations to elucidate cosmological history. Superintelligent beings in this post-human stage must have also developed simulations at some point. In those simulations, they must have created new consciousness. Those consciousnesses must have evolved, become more complex, and built civilizations just like themselves. Remember, they are simulations after all. In the end, they must have wondered about their own existence in those simulated consciousnesses and tried to create their own simulations. The consciousnesses that emerge in the simulations they create are the same way. In other words, whether in a simulation or not, every consciousness must have tried to better understand their own past and existence by creating hyperrealistic simulations when they reached a sufficiently advanced technology. And if the four assumptions we just made are true, these simulations are just like a matryoshka doll. Must be of an interlocking nature. The consciousness in each simulation must create its own simulations, and perhaps this must continue for thousands, millions, perhaps trillions of layers, if there is enough time. Okay then, I'm asking you, if you were to be born in a random place in a series of simulations consisting of trillions of layers, what are the chances that you are in the real universe in that first layer that will create the first simulation? Practically zero. If you were to randomly place your finger on any layer in this huge chain, that layer would almost certainly be a simulation that had been simulated by the previous ones. So you are almost certainly in one of those layers right now. You are not the actual layer that created the original simulation on top. How? Creepy, isn't it? Nick Bostrom, an Oxford University philosopher who first put forward this argument, wrote in 2003, "Are you living in a computer simulation?" In his article titled, he does not actually directly claim that we are living in a simulation. Rather, if we are not living in a simulation, we are not making assumptions of the kind we have just considered. Points out that at least one of them must be at fault. And whichever of these assumptions is wrong, it would give us very interesting perspectives on ourselves and our civilization. Just think about it. Unless we are in a simulation, our technology may be programmed to destroy us at some point. Or biological evolution may not be able to create a species intelligent enough to avoid self-destruction. Or consciousnesses may be specially created structures in the universe, or simply, they may not be interested in their existence, the structure of the universe, or their past. Each of these are groundbreaking possibilities. But maybe all the assumptions are true. We would inevitably have to conclude that we are living in a simulation. So both possibilities are truly dizzying. And in fact, simulation theory is not just a fancy possibility. It also helps us explain some of our most interesting observations about nature. For example, the event that the probability distribution of a measured quantum system collapses into a single reality, which we talked about in previous videos, that is, the measurement problem, as it is scientifically called. Thanks to this argument, it is sort of solved. Because if we are in a simulation, there should be no need to simulate everything in the universe at every moment. Otherwise, the processing power of hypercomputers would be wasted. For example, if you leave your cell phone in the living room while going to the toilet, that phone, and even the living room, should not continue to be modeled. The simulation of your phone will end the moment you leave it, until you head back to the room to retrieve it. In other words, simulating only the parts where a consciousness is focused or a real measurement is made is sufficient for a sufficiently realistic experience. And this is how virtual environments are created in VR headsets today, selectively depending on where you look. It doesn't calculate all of them at the same time. Likewise, simulation theory is famously mentioned in The Matrix. This is déjà vu, or everyone thinking Pikachu's tail is striped. Or the Mandela effect, which we use to describe mass phenomena such as the belief that Nelson Mandela died way back in the 80s. That's all well and good, but it's very, very likely that you're not living in a simulation right now. First of all, the measurement problem that I said the simulation argument can solve. Or things like déjà vu have much simpler, more plausible explanations today. But more importantly, the assumptions of the simulation argument are not that easy to swallow. First of all, the fact that the universe can be computerized from beginning to end is a very, very big assumption. Although we have not discovered any properties that cannot be simulated on a computer so far, perhaps properties like superposition or entanglement that we encounter in the quantum world, or human consciousness, or the absurd enormity of the universe. Or, if real, free will, perhaps cannot be simulated. We don't know, similarly, in light of our current knowledge. We also do not know whether the space-time fabric is quantized, that is, composed of discrete particles. If the space-time fabric is not quantized but continuous, then it may be very difficult to simulate it realistically on a computer. Because computers generally need minimal units like pixels, iterations, or time pulses in order to simulate something. Also, Gödel's incompleteness theorem, which I will explain to you in the following videos, says that some truths in formal systems cannot be verified within that system itself. This is also physical. This means that there may be some logical limits within personal universes that cannot be transferred to simulations or predicted. Similarly, the subject of chaos theory that we talked about in the past weeks, deterministic chaos, may contain elements that will push the boundaries of our simulations. But these are not the reasons that convince me that we are not living in a simulation. There are three other reasons that are much more important in my opinion. The first is fundamentally based on the law of entropy. The computers that run these simulations that I am talking about will need an absurd amount of energy. So much so that some experts, even in our universe alone, they think there is not enough energy to run such a simulation. But let's say even if there is, the resolution of the simulation we create must include some losses due to the laws of entropy. Therefore, the simulation we will create will have to have a lower resolution than the simulation we might be in right now, that is, the universe itself. The reason I focus on resolution is that the limits of resolution are ultimately it is determined by physical energy sources, and as resources become insufficient, the resolution will decrease. As the resolution decreases, the consciousnesses living in that simulation will be able to notice. There will be some distortions that become more obvious with each layer. And these disruptions will increase exponentially. Because just think about it, if there was a 1,000-layered simulation, that is, 1,000 layers within the simulation, within the simulation, within the simulation. If there were nested layers, the top layer would have to have enough energy not only for its own simulation, but also for the simulations within it to run. It's a mind-boggling amount, and it also means that resolution degrades further with each simulation layer. But we don't see any such obvious resolution problems in our own universe. So either we are in one of the simulations at the top layers by chance, or we are not in a simulation. But I think the second reason is much more important. Simulation theory assumes that each layer creates its own hyperrealistic simulations. The problem is that we don't yet have hyperrealistic simulations with living consciousness in them. Isn't that right? If you think about it, this is a huge problem for simulation theory. In this case, we are talking about those trillions of layers. We must be the last. But that's for the reasons we just discussed, statistically as unlikely as being at the very beginning of the simulation chain. And the fact that this universe is real. Since it is based on fewer assumptions than if it were simulated, public opinion tells us to eliminate the more complicated possibility. Therefore, I don't think we are living in a simulation right now. We are in the real universe. And there's a third, much more important reason. Burden of proof. The burden of proof is on the shoulders of the make the claim. People who defend the simulation argument, like Elon Musk, have not proven their claims empirically to satisfy scientific standards, and frankly, it's extremely unclear whether this argument can be verified in any way. It seems like a pretty unfalsifiable hypothesis, and that makes it unscientific. So the concept of the null hypothesis in science credibly convinces us that this claim is true. So when we encounter an unproven positive claim, we will accept the opposite as true and then try to disprove our new assumption. So that we don't kid ourselves, if we can disprove our null hypothesis, that is, the assumption that we are not currently living in a simulation, great. Then we will have proven that we are indeed a simulation. But if we can't disprove it, then we will not have jumped into an unproven claim in blind ignorance. Science is so powerful because of this method. Here it is. For all these reasons, I think we are not currently living in a simulation. But I'm completely open to your ideas. Don't forget to share them with us in the comments, and look on the bright side. Maybe that crazy possibility is real and What would a universe where you set your own rules look like? Be sure to share this with us in the comments. For example, in a world we would simulate initiatives that contribute to intellectual accumulation and raise public awareness would lack basic material needs. For example, if someone were working day and night to explain modern science to the public, basic conditions that would ensure their rights such as food, shelter, and rest would definitely be provided. But we do not live in such a simulation. The only thing that makes our work possible is our readers and viewers who support us through Criosis and the YouTube join button. If you find our work of quality and worth continuing, you can support us monthly or one time without straining your budget. Also, if you like this video, I also recommend that you watch this video about when we will rule our own galaxy. See you in the next video. Goodbye.